Okay, so today we're going to take a look at benzene. All right, benzene is something we've been talking about since the beginning, but I haven't really told you much about what it is. The benzene molecule is planar, which means that it's flat. It's planar hexagonal. So we've been talking about how important those six-membered rings are. Well, benzene is also important. It exists as a resonance structure of two contributing structures, which I'll tell about in a second. Benzene is more stable than either contributing structure. And here's the interesting part. There are no single or double bonds, only this intermediate type, okay? So these are called the Killuke structures right here, and they are isomers of each other. And when you first look at these might look identical to each other. But if you start to number the carbons, carbon 1, carbon 2, carbon 1, carbon 2, you'll see here that this one has a double bond and this one supposedly has a single bond. Benzene is neither one of these. It's kind of both combined. All right, so it doesn't have any true single or double bonds. It has six bonds that are kind of double-ish and kind of single-ish, which I'll show you a couple more pictures. Benzene's molecular formula is C6H6, so there is only six hydrogens attached to the outside, as you would expect in an unsaturated molecule. It's itself not very exciting. It's a colorless liquid. Its boiling point is a little bit less than water, and its melting point is a little bit more than water. And here is, like I said, here's benzene's planar hexagon structure. So all carbon bond lengths are identical in the benzene single, double, intermediate structure there. If you take a look here, you can see here are the pi orbitals. Remember, they come above and below the internuclear axis. Here are the sigma bonds, and these pi bonds and sigma bonds combine to make the structure that we know as benzene. All right. Sometimes this will even be described as a delocalized pi system, where these p bonds exist above and below, right? So each carbon atom has three sp2 hybrids and a p orbital. The p orbitals overlap and form those pi bonds that create a cloud above and below the plane of the ring. The six p electrons are said to be delocalized and they're free to circulate, okay? Here's the bottom line. All bond angles are 120. And so that 120 makes a very stabilized structure. This is one of the ways that we draw benzene, and I kind of like the way this one looks because this doesn't confuse people. This lets people know that there are these delocalized p electrons. Benzene was originally discovered in 1825 by Michael Faraday. This is the same Faraday that you would have learned about in your physics class. It was a pretty surprising formula because most hydrocarbons had twice as many hydrogens as carbons, but we know that benzene is unsaturated. So it does not have twice as many hydrogens as carbons. However, benzene doesn't show the behavior of unsaturated compounds. And we'll talk about this more later when we talk about some of the reactions that benzene goes through. But this is why it was such a surprise. It didn't have the correct number of hydrogens for it acting so saturated. These are benzene molecules, and we call them aromatic hydrocarbons. They're called this because they often produce characteristic aromas. In fact, benzene itself is has a nice aroma to it. Early aromatic compounds were obtained from resins, essential oils, distilled from plants or flower petals. A lot of those essential oils that you guys have today in your little diffusers will have some of these aromatic compounds in them. Notice here, there are a few examples. We've got toluene used in glues and paints, definitely stinks. Naphthalene is one that's used in mothballs, actually causes some cancer now. Here's ones that used to make plastics, and then this one is a precursor for styrene or styrofoam. So the IUPAC names for benzene, before we talk about any ways that we're going to use benzenes, I just want to make sure you're able to name them. They're going to be derivatives of the word benzene, right? So if you have a monosubstituted benzene, you're just going to name that group, and then you're just going to add the word benzene. So for example here, we can call this a nitrobenzene, or this one is an ethylbenzene, or a bromobenzene. And notice there's no ones or twos on those because, like the cyclical compounds, you don't need to write ones or twos. Some of the historical nomenclature is still around. A good example of that is toluene. You just heard me talk about toluene. You might want to call that methylbenzene because there's that methyl group, but this is known as toluene. This is benzene with an alcohol, and it's called phenol, and it's used for a lot of things. This is aniline, and this one is benzoic acid. So benzoic acid has carboxylic acid on it. So many historical names are still used today. I recommend that you memorize these if you can, but you will have your notes to look at. For di-substituted benzenes, you're going to name the first group position 1. If there's a special group, so there's a group according to IUPAC rules that deserves a higher priority, it must be number 1 on the ring. So that would be like a chlorine or an alcohol group would receive the number 1, and then your ethyl or methyl groups would be named after that. There is an older system of naming that is still around today, ortho, meta, and para. And those are pretty simple because if you draw a benzene, ortho is at position 1 and 2. Meta is at position 1 and 3. And para is at position 1 and 4. So we get those ortho, meta, and para coming up a lot in nomenclature. So you can see here, new IUPAC might call this 1-bromo-2-ethylbenzene, but old nomenclature would call it ortho-bromoethylbenzene. This would be 3-nitrotoluene. Remember I told you toluene is a methylbenzene, and it's a name that they still use very much today. This one is meta-nitrotoluene. And then finally, we've got one for dichlorobenzene or para-dichlorobenzene. Now, if benzene is a substituent, so if you have a long hydrocarbon chain, and off of the hydrocarbon chain is a benzene hanging off, so you can name it as a substituent, we actually call it a phenyl group, P-H-E-N-Y-L, not to be confused with a phenol group, right? So a phenyl group is what we call benzene when it's hanging off, and then a phenol group is a functional group that I mentioned before. I think I had a picture of phenol right there. So not the same thing. So here we go. We've got 3, 1, 2, 3 phenyl, 1 butene. If we attach a benzene ring to a carbon before we attach it into the chain, it's called a benzyl, which I really hate. When it's directly attached, it's called a phenyl, but when you attach it to a carbon first, and then you attach it to the R, the chain, whatever it is, we call this a benzyl. There can be a lot of benzenes in chemical compounds, okay? So these are called poly, meaning many, nuclear, polynuclear aromatics, right? Where they have a lot of these benzenes, and sometimes they're drawn with the circles, and then sometimes you'll see them with the every other thing there that they have written sometimes. So a few of these, naphthalene is in mothballs, anthracene is in coal, Benzopyrene is in cigarette smoke and other organic combustions. You can actually get it from your grill, and it is a carcinogen, which we will talk about in here. Finally, I just want to leave you with a couple things. There are some other significant hydrocarbons that you may hear about, and we're going to do a project on these, but mineral oil is one of them. It's found in a lot of your cosmetics. It is found in shampoos. You also can drink it if you want. However, it does cause some problems. Pheromones might be another one that someone might talk about in a project someday. It's a special kind of hormone that's excreted by animals. Acrylics or polyacrylics, such as plexiglass, really important right now during COVID because there's plexiglass everywhere. That's a type of acrylic. Here's plexiglass used in medical, but you can also use it to make really cheesy decorations for your tests or for your desks. Someone built a car out of it. It was actually discovered around World War II as windshields for airplanes.